Okay, so today we're talking about Chapter 10, Section 7, Solving Radical Equations. So everything that we have learned up to this point, we are going to be using it to actually solve these equations. But before we do begin, I believe this is, now I've been wrong about my dates before, okay? But I believe this is the second to last full week we have before the finals. We have this week, 2 days next week, and then a full week, and then we have finals, I think. I don't know. Again, I've been wrong about that before. But here we are near the end of the semester, and I don't know about you guys, but it's flown by for me. So solution. All right. So what? Um, that's all. That's all well and good. We don't need to read that though. Obviously, I put it on there for notes, but I feel like I'll do a lot of that explaining as I go. Solving a radical equation. Alrighty, so once again, we have our three-step process, or four-step actually. But again, there's not a hard and fast rule. You just kind of you just kind of know how to do it or learn to do it as you do it, right? One thing I want to point out is this step 4 right here. Okay, uh, I am going to conveniently skip that step for at least the first couple of problems, only to prove a point later on. Okay, so bear with me on that. But the first three, yeah, we're good. Alrighty, mainly because, well, there's a big finish. Okay, so anyways, let's begin. So example 1 reads solve the equation. So that's not hard, right? So the first thing I'm gonna do is I'm gonna go ahead and subtract 5 from both sides. So I'm gonna have the square root of p is equal to 9 minus 5 is 4. All right. Well, in order to solve for p, I need to isolate it, right? So what do I need to do here? It looks like I need to square both sides. Okay, and then that would give me p is equal to 16. All right. Now obviously I could put that in there and check it, but again, I really want to prove I really want that big finish, so we're gonna skip that part for right now. But that's how we solve, right? Similar to basically every other problem that we do have to solve. Whenever if we are adding from one side, we need to subtract from both sides, or multiplying, then we divide. In this case, we have a square root, therefore we should square, and that's what you see in the red. Okay, so let's go ahead and jump to example 2. Which one? Let's see. Okay, so example 3 would be the big one. Okay, so example 2. Solve the equation. So we're going to, all right, first of all, we need to isolate that w. Okay, so in order to isolate w, well, it looks like I need to add 2 to both sides. So let's go ahead and knock that out. So the cube root of w minus 1 is equal to, we add 2 to both sides, so it's going to be equal to 4. Okay, and then from here, it looks like I need to cube both sides because I'm taking the cube root, so I'm going to cube both sides. So, and then we've got w minus 1, and that's equal to 4 cubed is 64. All right, and then we add 1 to both sides, so w is going to be equal to 65. All right, easy stuff. All right, so example 3. Here is the whole point of what I've been trying to do. Okay, so let's begin. First up, we looks like we can just subtract 9 from both sides right away. Actually, no. Let's go ahead and rewrite it because we know that 1/4 power, we know what that's going to be, right? It's going to be 7 is equal to, if I see 1/4 power, that is essentially the 4th root of x plus 3, right? And then we have plus 9. So all I basically did was just rewrite the problem, right? Alrighty, so next, what I'm going to do is I'm going to subtract 9 from both sides. So I'll have a negative 2 is equal to the 4th root of x plus 3. Right. So I have the 4th root there, so I need to raise to the 4th power here. Okay. All right. And 2 raised to the fourth power is 16. And then if I raise that to the fourth root of x plus 3 to the fourth power, then that's just simply x plus 3. I'm going to subtract 3 from both sides. So I'm going to have x is equal to 13. Okay. Now x is equal to 13 is my solution. Okay. And for the first two examples, and realistically, pretty much for everything I've done in this particular course, I haven't checked my work. Okay, now obviously checking your work is a good thing to do, especially come test time, because, well, it checks your work, right? But if you're, and I'm sure many of you are like myself, you're just kind of like, okay, well, hope I got it right and I'm moving on, okay? I don't think you check your work every single time. But here's the thing. If you are going to if you're going to solve equations and you're raising to an even power, okay, and here we see we're raising to the fourth power, which is even. If you're raising to an even power, you 100% of the time must check your solution, because something comes up whenever we square both sides, something called an extraneous solution. Okay, and that makes sense because, well, first of all, let's just examine what's written in the blue here. Okay, what's written in the blue there is basically saying, okay, so if I were to, no, let's see here. How do I word this? No, let's not go there. I feel like I'll confuse myself there, okay? But anyways, whenever you square numbers, obviously an even number squared a positive number squared is positive, but a negative number squared is also positive, okay? So funny things happen when you start raising things to an even power, alrighty? And we're going to see that here. So first of all, we have the solution x is equal to 13, right? Well, let's plug x equals 13 into our original equation. So our original equation was 7 is equal to the fourth root of, and then we had 13 as our solution, 13 and then plus 3 plus 9. Okay, so we got 7 is equal to, all right, so 13 plus 3 is 16. The fourth root of 16 we said was 2. So 2 plus 9. So 7 does not equal to 11. Okay, so because this happened the way it does, then the solution here is the empty set. Okay, the empty set would be what we call our solution, the empty set. Okay, x equals 13 is not a solution here, because when we plug it back in, it becomes an extraneous solution. Now, let's see. Now that I've mentioned that, let us go back to here. Okay, I didn't want to touch on this just yet because I wanted to point out exactly what an extraneous solution is when we see it in practice. Okay, so, well, honestly, I don't know if I have to actually read that, mainly because I feel like this example actually does a good job of bringing that point home. But to recap, no, you don't necessarily have to check your solution in mathematics most of the time to see if you got it correct. Obviously, checking your solution helps. All right, again, come test time, because you don't want to speedily rush through your problems on a test. Okay, but in certain circumstances like this one, whenever you raise a side to an even power, then you must always 100% of the time check your solution. Right, and then we're going to see more and more examples of that as we proceed throughout this lecture. Alright, so solve the equation. First thing I'm going to do is I'm going to go ahead and subtract y from both sides. So I'm going to rewrite this as 2 on the square root of 4y minus 3. That's going to be equal to, we subtracted y from both sides, so it's going to be 3 minus y. Alrighty, and then from here, we're going to have to, looks like we're going to, alright, so before I do proceed, you can, if you want to, actually no, I highly suggest against it. Okay, so let's talk about that now. I need to isolate the y here, right? So the y is on this side on the left, and the y is on this side on the right. Okay, and we've learned that in order to isolate the y, we have to put everything on one side, right? You may be tempted to, because we will see we need to isolate this radical in order to get rid of it. Correct? I mean, while that is true, If I were to take this and divide both sides by 2, that would take care of that. But then I have this janky looking fraction over here, and nobody likes janky looking fractions. Am I right? So we're going to not do that. All right. Instead, what we're going to do is we're just going to go ahead and raise both sides to the we're going to raise both sides to the second power, and that's going to take care of that radical without having to divide both sides by 2 and getting that janky looking radical, right? Because we know from our power rules that this becomes 2 squared, and that's going to be the square root of 4y minus 3 squared, right? By our central power rules. It's kind of like a reverse distribution property there, right? But it only works if there is a multiplication here, right? If there was an addition sign there, then we couldn't do that. Right? So let's proceed. So 2 squared is 4, and it's going to be 4 times 4y minus 3. Again, we are squaring that square root, and that's going to be equal to, and matter of fact, I'm really glad the right side looks like this, because again, we cannot, because this is a minus sign there, we cannot do 3 squared and y squared. It's not going to be 9 minus y squared. Okay, that is not true. This is a problem that many students have, including calculus students, because you forget things, right? If you don't use it, you lose it, right? So instead, we do know that this is actually the same thing as saying 3 minus y times 3 minus y, right? Because it's 3 minus y squared, right? But we also know that 3 minus y, or we also know that that is in the form of a minus b quantity squared, which we should know to be a squared minus 2ab plus b squared. Okay, so that's how we're going to proceed there. So a squared is going to be 9 minus 2 times a times b, so it's going to be minus 2 times 3, which is 6, times b, which is y, so it's going to be minus 6y. And then it's going to be plus b squared, so it's going to be plus y squared. Okay, so hopefully you followed along there. All right, well, I need to isolate the y, and so I'm going to go ahead and distribute here on the left. So I'm going to have a 16y minus 12 is equal to 9 minus 6y plus y squared. All right, so I'm gonna actually let's go ahead and put the right side in descending order. Okay, so we're gonna already put it in descending order because this is definitely looking like quadratic. Ready? And then I'm going to subtract everything from the left side and put it on the right side. So I'm gonna have 0 is equal to y squared. And if I subtracted 16y, so it's going to be minus 22y. I'm going to add 12, so I'm going to have 21. Ready? All right, so now I need to solve here. So we can do this one of two ways. We could either factor it, or we could use the quadratic formula. Well, here's my rule is if I can factor this in my head within 3 to 5 seconds, I'm going to do it. And it looks like I can, right? I mean, it looks like my factors of 21 are 1 and 21, and that will give me negative 22. Right? Now, obviously, if I couldn't factor that in my head within 3 to 5 seconds, what I would do is I would just go to the quadratic formula, because I'm not going to sit there and try to factor it in my head for too long, right? Oh, it's not y squared. It's going to be y. Let's put parentheses there. It's going to be a y. What did I say? Minus 21, and then a y minus 1. Okay? So this tells me my solutions are, here, our y is equal to 21 and y is equal to 1. Alrighty? But again, we're going to have to check these solutions. Right? Because, well, my very first step up here, I squared both sides. So I need to check them. Again, there's no way around it. You have got to check your solution. If you don't check your solution here, you're going to get tricked and you're going to have an incorrect problem. Okay? Or an incorrect solution, sorry. So let's look at it, or an extraneous solution is what they're called. So my original equation, we'll put this in, we'll put it in red. All right, so it's going to be y, let's start with 21 first. So it's going to be 21, and again, I'm just replacing y with replacing my solution with y in my original problem. So it's going to be 21 plus 2 on the square root of 4 times 21, so 4 times 21 minus 3 is equal to 3. Right? Okay, well 4 times 21 is 4 to 84. 84 minus 3 is 81. The square root of 81 is 9. Right, so it's going to be 21 plus 2 times 9, which is 18. It's equal to 3. Okay, and we know that is not true, right? 39 is not equal to 3, so y is equal to 21 is not a solution. Okay, now let's do 1. So we've got 1 plus 2 on the square root of 4 times 1 minus 3 is equal to 3. So we got 1, and then, all right, so 4 times 1 is 4. 4 minus 3 is 1. Square root of 1 is 1. 1 plus 2 is indeed equal to 3. So y is equal to 1 is a solution, right? So that's how we solve this problem. So apparently y equals 21 would be our extraneous solution, right? And an extraneous solution is it's where you do everything correct, but you're incorrect, right? The algebra works out, but when you actually plug it into your problem, it is incorrect, right? So again, make sure that you always check your solutions whenever you start raising things to even powers. Okay, and that leads us to odd powers. Now, the textbook actually does check the solution. Pretty sure, right? Yeah, it actually checks the solution. But the thing is, you don't have to check solutions for cubes. Okay. Thought we messed up there. Now, this is pretty easy. Well, easier, right? Because we have cubes on both sides, so therefore we are cube roots on both sides. So therefore we must cube both sides, right? And when we cube both sides, then all that remains would just be the radicands, right? Or the numbers that are inside my radical. Right? And then we solve from here, so let's go ahead and add, we're going to add 8x, we're going to have 10x. We're going to add 4 to both sides, so it's going to be 5, so x is equal to 1/2. Right? And we're done. Okay, again, the book does check it, but since we are raising to an odd power, we don't have to. The reason why is because, I mean, nothing really happens with odd. I mean, they do, but okay, so maybe this is too much. Maybe this is too much, but we'll learn this in college algebra, and we might have learned it here as well. But the domain of even, you know, x to the n power where n is even, the domain of these functions, well, it should actually be the root. The domain of these functions are from 0 to infinity, right? And hopefully that makes sense because I know that I cannot have a negative number in here. If I have a negative number inside there, it will be an imaginary number, okay? However, if n was an odd number, then the domain is all real numbers. Okay, which is why I say that, you know, we don't have to check it if we're raising to an odd power. Hopefully that's not too much, but there it is. Of course, the book does go about checking, so whatever. All right, example 6. Okay, so I got really bad news for you. There is no easy way around this. You must solve. You must take care of these radicals one at a time. Alrighty. So what I mean by that is we need to isolate one radical and then solve, and then isolate the other radical and then solve. So let's go ahead and isolate one of the radicals. So we're going to go ahead and we're going to add the square root of n plus 4 to both sides. So we're going to have square root of 3. That is a horrible m. That isn't even an m. That is, okay, my pen. I'm going to blame my pen, right? My pen's not working. All right, there we go. Is equal to 1 plus the square root of m plus 4. No, seriously, my pen wasn't working there. Anyways, we need to square both sides. Okay. So the left side, well, that's pretty easy. The whole point of that, right? And then the right side, again, the right side, we're going to be following along with the formula. Okay, this is in the form a plus b quantity squared. you are going to, those that don't pay attention are going to make this mistake many, many times, and you're going to be really frustrated. You're like, math doesn't make sense. But I've told you that this is what you do, right? So a plus b squared is, again, a squared plus 2ab plus b squared. Okay? It is not a squared plus b squared. No, 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 don't do that. Okay? Because, well, that doesn't make sense, right? There is no such thing as a sum of squares. We cannot factor a sum of squares. But anyways, I digress. So it's going to be 1 squared, right? 1 squared plus 2 times a times b, so it's going to be 2 on the square root of m plus 4 plus b squared, which is going to be just simply m plus 4. Okay, and then like I said, we're going to have to isolate that that second radical. So we're going to go ahead and let's just put all these on the left side all in one manner, right? So this 1 and this 4 is a 5. We're going to subtract 5 from both sides, and we're going to subtract m from both sides. Okay, so we'll have 2m, and then we subtract 5 from 1, so that's going to be minus 4 is equal to 2 on the square root of m plus 4. Okay, now this is interesting. We could, if we wanted to, we could go ahead and we actually can divide both sides by 2 here. Okay, because this would just turn into m minus 2. But because I don't want you to get into the habit of it, we're not going to. Right, and I'm pretty sure the book actually does divide both sides by 2. So there is going to be a little discrepancy between what I do and what the textbook does. But anyways, let's go ahead and we're going to square both sides again. So we're going to have, the left side becomes a squared, which is 4m squared, minus 2ab, so it's going to be minus 2 times 2, which is 4m, 4 times 4 is 16, so it's going to be minus 16m, and then plus 16. 2 times 8, yeah, okay, good. And then the right side is going to be equal to 4m plus 4. Okay, so let's go ahead and distribute that on the right side. So it's going to be 4m squared minus 16m plus 16. That's going to be equal to 4m plus 16. Let's move everything to the left side. So we're going to have 4m squared. Looks like minus 20m. And then that's it. Good. Is equal to 0. Because we subtract 16 from both sides, and 16 is going to cancel out. It looks like we can, let's go ahead and move this up here. Okay, so we're going to divide both sides by 4. So we're going to have 4, we're going to have m squared, but no, I'm sorry, we can factor 4m out. Sorry about that. Looks like we'll have an m minus 5. So m minus 5. Okay, and that's equal to 0. So this tells me that m is either going to be equal to, looks like 0, or m is going to be equal to 5. Okay, so again, no easy way around it. We must plug our solution in. So let's go ahead and plug in a 0. Well, plugging in 0 is actually going to be pretty easy, right? I'm looking at my original equation. So plugging in a 0 would just be what? The square root of 1 minus the square root of 4, and that's equal to 1. And square root of 1 is 1. 1 minus 2 is equal to 1. We know that is obviously not true. So 0 is not a solution. Now let's plug in a 5. So we've got, let's just do this in our head. Well, kind of in our head. All right, 5 times 30 is 15. 15 plus 1 is 6. The square root of, it's 15 plus 1 is 16. The square root of 16 is 4. And then minus. And then 5 plus 4 is 9. The square root of 9 is 3. And that does indeed equal to 1. So my solution to this equation is going to be m is equal to 5. In one moment, I need to turn my heater off. like to sleep freezing cold, but then I wake up freezing cold, and then I go overboard on my heater. Alright, so what did I say earlier? Oh yeah, that said they checked it. Okay, good. Oh my, more doing it both sides here. Alright, solve the equation. So we need to. It looks like it's already set up for both sides. I need to. I'm sorry, it's already set up to where I don't have to isolate a radical because the radical is already isolated. So I'm going to go ahead and start this off by squaring both sides. You know, kind of imaginarily squaring both. Maybe I should put that in blue. So I'm just going to erase it. So I'm just going to go, kind of imaginarily square both sides there. So we're going to have 5x plus 4. And that's going to be equal to a squared, which is 1, plus 2ab, so it's going to be plus 2 times the square root of 5x minus 3, and then plus b squared, which is going to be 5x minus 3. Alrighty, well this interesting. Okay, so we need to isolate this radical. So it looks like if I subtract 5x on both sides, they're going to cancel. 1 and a negative 3 gives me negative 2, so I'm going to add 2 to both sides. So I'm going to have a 6 is equal to 2 on the square root of 5x minus 3. And that's interesting because it's also set up to where I can divide both sides by 2 again. It's interesting that this textbook takes that route because, again, I don't want you getting into that habit because we will end up like I said earlier. I said what, a janky fraction. We don't want to do that. So I'm gonna try and stay consistent here and not do that there. Okay, so we're gonna go ahead and square both sides again. So we're gonna have 36 is equal to 4 times 5x minus 3. Alrighty, so I'm gonna go ahead and actually I don't have to do that. Okay, so let's go ahead and distribute real quick. So we're gonna have 20x minus 12. We're gonna add 12 to both sides. So we have 48, and then we're gonna have let's go ahead and do that. 48 is equal to 20x. We divide both sides by 20. We end up getting what? 20, 24, 10, 12, 5, 12 fifths. 12, oh, that's not 12 fifths, that's just 12 fifths. All right, so 12 fifths. So now we have to plug our 12 fifths into our original equation. So we're going to have, good. Okay. So it's not so bad because they set it up to be not so bad. So 5 times 12 fifths plus 4 is equal to 1 plus 5 times 12 fifths. That's horrible. Minus 3. Okay, I said it's not so bad because we see that our 5 is going to cancel on both sides, right? So it ends up being 12 plus 4 is 16. The square root of 16 is 4. It's equal to 1. And then 12 minus 3 is 9. Square root of 9 is 3. So 1 plus 3. So yeah, 12 fifths is indeed the solution to this equation. 12 fifths. 12 fifths. All right. Applications. All right. So we're going to have some pyramid applications. There. All right. Alrighty. So, for a pyramid with a square base, the length of a side of the base B is given by, again, the side of a base. So, okay, so the base is just a B, okay? But the side of the base would be the square root of 3 times the volume divided by the height. Okay. So it goes on to read, the pyramid of the Pharaoh Khufu, known as the Great Pyramid at Giza, has a square base has a square base. If the distance around the bottom of the pyramid is 921.6 meters and the height is 146.6 meters, what is the volume of the pyramid? Okay, so this is interesting because we're now gonna be looking for the volume. Okay, so let's go ahead and take our equation. Okay, and since we're wanting the volume, let's go ahead and solve for v. Ready? So it looks like it'll be if you square both sides, we'll have b squared is equal to 3v divided by h. We're going to multiply both sides by h, so we're going to have 3v is equal to hb squared. And then if we take that and we solve for v, then we'll have v is equal to, let's move it down just a tad. We'll have v is equal to hb squared. I mean, I guess that's fine. hb squared divided by 3, right? And so that is the new formula for the volume. So it reads, we're looking for, okay, so the height is going to be 146.6 meters. All right, so the height is going to be, let's put that, we'll put it right here. The height is 146.6, 146.6. All right, so I need to find b. All right, so how do I find b? Well, in order to find that, I need to substitute my base and my height. I'm sorry, my base is 921.6 meters. So what we're going to have to do is we're going to have to take that and divide it by 4. Okay. So real quick, why am I taking this base and dividing it by 4? Well, because I know that, you know, it's a square. It says it's a square base, right? So I know that the sides are all going to be equal to one another. And if the entire thing is 921.6 meters, then each leg must be a fourth of that. So that's why I'm dividing by 4. So 921.6 divided by 4, 230.4. So my base is going to be 230.4. All right, so I got my h and b, and I can plug those in for h and b there, and I'll figure out my volume. So let's go ahead and do that. All right, so it's going to be equal to, my height is 146.6 times 2, oh man, that's going to be huge, all over 3, which would be equal to, okay, I'm just putting this in the calculator, 0.4 squared. Alright, so it is indeed a humongous number. It's going to be 2,594,045. Okay, square meters, or cubic meters. Sorry, cubic meters since it's area. All right. So, anyways, I feel like I don't know if I actually kind of taught that one, did I? Let's recap it, right? So we have a pyramid with a square base, good. All right, we have the length of the side of the base being given by, boom, okay? So we're asked to find the volume of this pyramid. What is the volume? Alrighty, so in order to do that, I needed to solve for v, as in volume, in my original equation, which I did here. Okay, solve for v. Alright, so once I solved for v, I needed to find out what my height and base is, right? Well, the height was given to us at 146.6 meters, and the base, all right, we weren't necessarily given the base. We had to just kind of think just a little bit, maybe rub two brain cells together and say, okay, well, you know, square base, the entire base is 421.6 meters around, so therefore, if I take that and divide it by 4, I get 230.4. And then once I got my two numbers here, all I do was plug them in, and then did some calculator tricks, right? And then got to my volume at 2.5 million cubic meters. Right, so maybe the recap it was clearer. And I believe this would be the last problem. Alright, so on a certain surface, the speed s of x in miles per hour of a car before the brakes are applied can be approximated from the length of its skid mark, right? So there's some forensic mathematics for you. So if we see a skid mark, and depending on how the length of the skid mark, we can figure out just how fast a particular vehicle is going, and it looks like it's in feet per second. So that's good. Everybody drives in feet per second, right? But anyways, oh, never mind. Here it is, miles per hour. I'm an idiot. Okay, so here we go. So it says find the speed of a car before the brakes are applied if its skid marks are 361 feet long. So let's go ahead and real quickly rewrite my equation and kind of break down exactly what I'm looking at. Okay, so what exactly am I looking at? Reading here, it says on a certain surface the speed s of x in miles per hour. So the speed of a car, this s of x is the speed of a car. Okay, and again, s of x is essentially y, right? So we can think of it like that. Can be approximated from the length of its skid mark x in feet. So x is going to be in feet. So that takes care of both of my variables here. Okay, so now I know what I'm dealing with. Right? So A reads, find the speed of a car before the brakes are applied if its skid mark is 361 feet long. Okay, so if this, let's just go ahead and rewrite it actually, just to really kind of drive the point home. Because I feel like s of x might throw you off, but again, it is simply just a variable. It is a variable of speed in miles per hour of the car. Okay, so anyways, now let's work on A. A reads find the speed of a car before its brakes were applied. So what I need to do is I need to just solve for y, right? Because s of x and y, they're the same thing. And we're given the length of the skid mark, which is 361 feet. So we're going to have y is equal to 3.8 on the square root of 361, which is a nice even, or nice not even number. So let's go ahead and put that in there. 3.8 times the square root of 361, we get 72.2. Okay, so what this tells me is if we see a skid mark 361 feet long, then we know that that vehicle was going 72.2 miles per hour. Okay. B, how long would you expect the skid mark to be if the car had been traveling the speed limit of 50 miles per hour, round to the nearest foot, okay? So if the car is traveling at 50 miles per hour, all right, that's going to end up being the y side, right? So it's going to be 50, and it's going to be equal to 3.8 on the square root of x. So I need to solve this for x. So the first thing I'm going to do is I'm going to divide both sides by 3.8. 13 points. We'll do 1.6 since we're going to square it anyways. Okay, and then we're going to take the square root. We're going to square both sides here. So we're going to end up with x is equal to, what is that squared? 173. It says to the nearest foot, so let's put, it's not an equal sign, let's put little squiggles, 173. Okay, so if you're going about, if you're going the speed limit of 50 miles per hour, then we can expect skid marks around 173 feet long. I believe that is the last example. It is. Alrighty, so that does conclude today's lecture.